everyone, this is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So today I am going to solve some of the problems from Standard 9. So it is again from Chapter 8, Motion, and today's topic is Acceleration. So in my last video for 9th Standard, I had uploaded about average velocity. So this is just a continuation of it. So uh, for a uniform motion, that is for a straight line, that is if an object moves in a straight line, the velocity remains constant. That is, there is no change in velocity from one point when you consider one point to the next one for a time t. So, uh, just remember this, that for a uniform motion, there is no change in velocity, and if you consider the change in velocity, it will be 0. So, this is a uniform motion. So, okay, for uniform motion, there is no change in velocity, it is 0, fine. But for non-uniform motion as such, where uh, there is a change in velocity at every time, right? If you measure the change in velocity from one point to the other point, there will be a change, exactly a change. So that change in velocity for a particular time t is given by the quantity acceleration. So acceleration is nothing but a measure of the change in velocity of an object per unit time. So this is acceleration, which can be written as change in velocity by time taken. And if the initial velocity is u and the final velocity is v, then in time t, then acceleration a is written as v minus u by t. So, and also just remember this, the SI unit of acceleration is meter per second square. Let us see our first problem, which says that starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second in next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So the first case is when he pedals his cycle, and the second case when he applies the brake. So let us see what is given. The velocity attained in time 30 seconds is 6 meter per second, and the velocity after applying brake for time 5 seconds is 4 meter per second, and we have to find the acceleration. So we know the formula, which is a is equal to v minus u by t. Let us see the solution. So here is Rahul, who is pedaling, but from the stationary motion he starts his pedaling. So at the stationary motion, his velocity will be, initial velocity will be 0 meter per second, 0 meter per second, and when he pedals, he attains a velocity 6 meter per second. So his initial velocity will be 0 and final velocity will be 6. Now, uh, now when he applies brake, his velocity changes to 4 meter per second. So this is the second case. So let us see the first case, whereas initial velocity is 0, final velocity is 6, time taken is 30 seconds. So this happens in 30 seconds. So we are just going to directly substitute in the formula, and we are going to get A as 0.5 meter per second square. So let us see our second case, where he applies brake. So before applying brake, his velocity was 6 meter per second. So that is our initial velocity. And the final is given as 4 meter per second. And the time taken is 5 seconds. So we are again going to apply in our formula, and we are going to get acceleration to be minus 0.4 meter per second. So by applying brake, we basically go against acceleration, right? So that is what is given by this minus sign. So let us see our next problem, which says that a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. It is a direct question where you have given the initial and final velocity and the time. You have to just substitute in the formula. So here the initial velocity is 80, final is 60, and time taken is 5 seconds. So we have to find the acceleration, which is given by the formula A is equal to v minus u by t. So let us see the solution, and here this is important. So let us see the solution now. We have our initial velocity and final velocity in terms of kilometer per hour. So we are going to change it to meter per second. So my initial velocity on converting it to meter per second gives 200 by 9. And my final velocity on converting to meter per second gives 150 by 9. So I know that acceleration is v minus u. So on doing it, I get my acceleration to be minus 1.5 meter per second. So this says that the bus has applied brake. So I hope you understand this. Let us see our next problem, in which a train starting from a railway station and moving with a uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. So this is also direct, where the initial velocity is 0 because it is starting from a stationary state. And the final velocity attained is 40 km per hour. And time is 10 minutes, which I have converted to seconds, which is 600 seconds. So we have to find the acceleration. We know the formula. We are going to substitute. So let us assume the train is in its stationary position, and in 10 minutes it has attained a velocity 40 km per hour. Right? So our initial is 0 meter per second. Final is 40 kilometer per hour. We have to convert it into meter per second. So it's directly into 5 by 18 and I get 100 by 9. So I'm just going to apply it in my formula. So on doing that, I get 100 by 9 minus 0 by 600, which is around 1 by 54. So on simplifying it, I get my acceleration to be 0.0185 meter per second square. So you always have to remember your formula and your SI unit. So I hope you like the videos and stay tuned for more videos on standard 9, 10, 11 and 12. So thank you. Like my videos, share my videos, subscribe my channel and also hit the bell. Only when you hit the bell, you're going to get my notifications. So thank you. See you tomorrow. Ta-da!